Good morning. It's still morning, Jersey. How are you? So we have a student today. So we'll start with some questions, and then we are recording, and we're going to record our lecture for about an hour, and then I'll hang around to see if people have any questions. Jersey, can you hear me? Seems like you. Can you hear? Okay. Okay, wonderful. So do you have any questions? If you could just unmute yourself, it's hard to read the text while looking at the screen. I don't have direct access to your text. Do you have any questions? For some reason, I cannot hear. That's better. Okay, Jersey, texting quite doesn't work, unfortunately. It's hard for me to pay attention to the class, but just turn on your mic and talk briefly. I will start with this. If you have any questions, if anything you want me to go over, just tell me which ones you want me to do or which one you want to start with. Since you're here, I'll start with that. How's that?
Yeah, that's good.
Okay, so I know we are being recorded, so I'm going to kind of talk to the whole class a little bit. Then I'm going to tell you where I would start. But if you want me to start somewhere else, you have a question like, could you do that again? Those things are totally fine and not a problem. So if I'm not mistaken, I have my notes. And again, I'm talking to everybody. It's an interesting situation. Let me open our packet. I think we should be able to wrap up fractions too. So these are my notes from previous class. And I'm going to go over a little bit about where we are and how we are doing things. This was mentioned last class as well. I think we stopped at 30. We did beyond 30. I know that. 47. We did that Lauren, and then we did one more. So the problem is already getting hard. We stopped at 53. Okay. So those of you who are watching this video a little later, we have done 53. Okay. What do these problems mean? Okay. So these problems will show up on exam 1, just these ones. If we do a few from here, which we might, they will show up as well. Now, right now, we're only concerned about the fractions 2 packet. Where is this packet? The packet that I'm working on is in problem sets, fractions 2. I'm only working on those few problems. There are many more, and the answers are there as well. There's a second document that has the same problems with the answers. You can choose to access whichever one you want. So the idea is we did 53. We're going to go back to our list and do the next one. So 60, 66, 67. Now these problems are going to get a little more challenging. We did 60. We did 60. Let's see. Yesterday. And we did 2 versions of 60. So let's see what's coming up. 66 and 67. Let's see. Let's see what they're like. All right, guys. This is a difficult problem, and I'm going to do a couple of variations. All right. Your book has one problem. Yeah, you can see the answer. I'm gonna push this guy down. We have 2 people. All right, Brianna, how are you? Okay. So this problem is from, it's a challenge problem from a middle school text, okay? I changed some of the fractions and I'm gonna do it very, very carefully, okay? It's a fairly difficult problem. So give me your full attention if you're here, and if you're listening later, I expect the same. All right, now let's read the question together. Alex, Betty, and Chris are trading marbles. First, Alex gives Betty 1/3 of his marbles. Let's change the color to blue. Then Betty gives, so Betty gets some marbles from Alex and she has a new number. She takes 1/4 of that and gives it to Chris. Sorry, yeah, Betty gives it to Chris. And then finally, Chris receives some marbles from Betty. We don't know how many he received. We don't know how many he had. And he grabs 5 of those and gives it to Alex. Everyone ends up having 9 marbles. How many marbles did each person start with? Okay, it's a fairly difficult problem. Now, I know some students want to write an equation. Be my guest. Be my guest, write it. I think you're going to find it a little challenging. It can be done, but the questions are very ugly. One more thing I'll mention. It came from a 7th grade book. They don't expect you to write a set of 3 equations with A, B, and C. The numbers of A stands for Alex's number, B, Betty's, and C, Chris's. That's not the purpose. You can do it. I will give you credit if you get it right, but I'm going to do it visually. Let me just double check I'm recording. I think I am. Yes. So I am gonna make a table. Okay, and I'm gonna work backwards. Okay, I'm gonna write here. We are working backwards. I'm gonna do at least 2 problems. In class, when I teach this, I spend a lot of time working backwards. It's a very very useful problem-solving technique. There are many problems in middle school texts that use this concept. Actually, guys, that's a good skill to learn. That's what really that's what I'm trying to say. Alex, Betty, and Chris. Now, since I'm working backwards, I'm going to write that they have 9, 9, and 9 marbles. This is where everything ended. I am going to undo very carefully each step. First, I'm going to undo the orange step. Finally, Chris gives Alex 5 marbles. Then I'm going to undo the green step. Then Betty gives Chris 1/4 of her marbles. And then Alex gives Betty 1/3 of his marbles. And guys, I'm going to be back. I need a little bit of tissue. Napkin tissue. All right. Sorry about that. So again, guys, I know we have a couple of people, which is a good sign. If you don't understand, you can slow me down. You can explain that again. I'll be happy to give you a problem. If you want to practice and present it on the board, that'll be absolutely wonderful. All right. So guys, I am now undoing the orange sentence. This happened right after Chris gave Alex 5 marbles. What was it like before Alex received 5 marbles from Chris? Well, give the 5 marbles that Alex got back to Chris. That's what I mean. So clearly, Chris must have had 9 + 5, 14 marbles, and Alex must have had 4 marbles. That's the only way. If Alex had 4 marbles and Chris gave him 5, he would end up having 9. And if Chris had 14 and he gave 5 to Alex, he would end up having 9. So that makes sense. So it's called undoing. If I say I give you $5, undoing it would mean you give me my $5 back. Okay, nothing at this stage where I'm going to be consistent with color. It's as I told you, it's a difficult problem, so I'm going to be consistent. So I just undid the orange sentence. I am going to put, and for Betty it's still 9. Okay, nothing happened to Betty this time around, but don't worry, she will interact too. So Betty, nothing happened. Chris just gave Alex, give those 5 marbles back to Chris. You're undoing it, and you have to understand, even though the question said Chris gives Alex, Chris's marbles should go down, but it has to go up because you're undoing that. Okay, next one is a little harder. The green sentence. In the green sentence, we're not being told that Betty gave 5 marbles. Betty gave 6 marbles. We are being told that she gave a quarter. So here's the rub, guys. Here is the rub. Okay, I'm going to write, this is Betty. I'm going to take, Betty gave a quarter. I'm going to draw a little picture. This is not a table. This is a picture for fractions. Okay. So, all right. So I'm going to read the green sentence once again. Betty gives Chris a quarter of the marble. That tells me after she gave a quarter, she was left with 9. And that tells me this has to be 9. That tells me Betty gave some marbles and she ended up having 9. If that's the case, each cell here has to be 3, 3, 3. And I'm going to go over this once again. So that green sentence and this picture that I have here that goes with Betty's name has 4 equal parts. And I know after she gave a quarter, she was left with 3 parts. And I took the 9 she was left with, divided it by 3, and I got 3. So each cell has to be 3. And this cell that she gave away is 3. So that means she has given Chris 3 marbles. We had to do all this work to just conclude that Betty must have given 3 marbles to Chris. Give those 3 marbles to Betty. How do we do that? Well, not really that difficult. Just the same thing. Add the 3 marbles. Subtract the 3 marbles. And nothing happened to Alex at this point in time. Leave him alone. I'm going to make this color green. Okay. Once again, to determine how many marbles Betty gave Chris, I had to do a little picture, and the picture allows me to conclude she must have given 3 marbles. Now double check your work. Take your 12. And what's 1/4 of 12? 1/4 of 12 is 3. If you subtract 3 from 12, what do you get? 9. And that's what she was left with. So I know I didn't mess up. I know I didn't make a mistake here. Let's pause here a little bit to see if people have any questions, those of you who are here. Okay. I am going to clear all my pink writing. Everything else will be here. I'm going to do the same thing for Alex. The blue line, same thing. Alex gives 1/3 of his marbles. Okay. That means he's left with 2/3. So I'm going to draw another picture here for I'm working on Alex's fraction. And he gives 1/3. So cut his this representation of all of his marbles has to be in 4 parts. Sorry, in 3 parts, actually. I'm going to erase one of them. Has to be in 3 parts because he gives away 1/3. Okay. And we know he was left with 4. So that tells me this has to be 4. If you give away 1/3, you're left with 2/3. And if you know you were left with 4, these 2 cells must represent 4. So I'm going to write 2 here, 2 here, and 2 here. And that tells me that Alex must have given Betty 2 marbles. Again, I had to draw a picture to come to that conclusion. So I'm going to make this a different color, maybe make it blue. All right. So now I did all this just to find out that if Alex gives away 2 marbles or 1/3 of his marbles, he is left with 4 marbles. And I am undoing it. And I'm going to go back and give Alex his 4 marbles, 2 marbles, my bad. And he gave it to Betty. So Betty loses 2 of the marbles that she received earlier from Alex. And Chris still has 11. Now I'm going to quickly go check my answer. I'm not done. 6, 10, 11 is my answer. Not bad. We got it. Now I'm going to work. So I'm going to pause here a little bit, guys. I'm going to pause here a little bit. What do you guys think? Anyone wants to share her ideas? What do you think, guys? Does that make any sense?
Yeah, it does.
Very good. I'm going to do one more. Okay. Oh, before I do one more, I am going to take this answer and I am going to show you that of course, my work is here, right? But I'm not looking at it. Actually, I'm going to push it down. I'm going to push it down. 6, 10, and 11. I'm going to hide this. And I'm going to make it invisible. I'm going to show you my answer is correct. So I'm going to work in the right direction. Okay, Alex, and I hope everybody ends up getting 9. Alex gives 1/3. 1/3 of 6 is 2. If Alex gives away 2, he is left with 4. If Betty receives 2, she ends up having 12. Nothing happened to Chris. 11. Okay, and I don't think I need to worry about the colors here. Colors are not going to totally match, but all right. Now what happened? We're working on Betty. Betty gives 1/4. 1/4 of 12 is 3. Betty loses 3 marbles. That's 9. And Chris gains 3 marbles. That's 14. Nothing happened to Alex. That's 4. All right. Finally, Chris gives Alex 5 marbles. This is easy. 5 from 14 moves, and that becomes 9. 9 stays 9. Nothing happens to Betty. 14 minus 5 is 9. So I know I checked my answer. I know my answer is correct. I'm going to do one more. Okay. I'm doing one more for other people too. So I'm going to do one more. And if you guys, then I'm going to give you a third problem to try. If you guys want to practice, maybe present. It's very easy to present. I'll give you 2 options. We'll see. Let me do one more. And just to let you know, Geraldine, Josephine, we'll do this one too, but I'm not going to worry about it right now. I'm going to do this one. We're almost done with this packet. Okay, so I'm gonna grab this problem from a different place, and I will give you guys some problems to try. I will put it on Blaze View, extra practice. Alex, Betty, and Chris, if people are listening to these videos, there will be a problem like this on your exam for sure. And it's a difficult one. Let me grab an Alex, Betty, and Chris. Okay, that's what I'm trying to do. All right, we're ready. Excuse me. Okay, let's do this one. Well, grab the answer just in case I mess up. Okay. Same kind of a deal. I am going to, hope I can wrap it up in, oh, I have time. Okay, I'm going to hide this. All right, so same kind of a deal. I'm going to go backwards. Go backwards, and I'm going to take a couple of columns here. Alex, Betty, and Chris. And I'm going to start with the bottom. They all ended up having 12. And of course, you probably should pause the video and read the question. But I'm going to read it for you. Alex, Betty, and Chris are trading marbles. First, Alex gives Betty a quarter of his marbles. Then Betty gives Chris a third of her marbles. And this time, Chris gives Alex 3. And they all ended up having 12. Okay, this line, I'm going to make it a different color. Make it orange and blue and green. All right, I'm going to first work on the blue-orange sentence, which is fairly easy. Chris gives Alex 3 marbles. Give 3 marbles back to Chris. He must have had 15. And take away 3 marbles from Alex. He must have had 9. Nothing happens to Betty. Of course, you should double check. 15 minus 3 is 12, and 9 plus 3 is 12 as well. So we're good. All right. Then Betty gives Chris 1/3. For this, I need a picture. Okay. So I'm going to draw a picture for Betty. If Betty gives 1/3, take all of her marbles. You don't know how many she had. Cut it into 3 parts. Okay. And she gave 1/3 away. This was her 12. This has to be what she was left with. Must represent this 12. Take 12 divided by the 2 cells. You get 6. Each cell has to be 6, 6, 6. I'm going to get rid of my pink writing. That's just for explanation. And I'm going to shade this. This is 12. So this picture allows me to conclude Betty gave Chris 6 marbles. Okay, I have to do all that. So give Betty her 6 marbles back. That's 18. And take away 6 marbles from Chris, and that's hopefully 9. Nothing happens to Alex. Leave him alone. Back to green sentence. Alex gives Betty a quarter. Okay, I can deal with that. Alex gives Betty a quarter of the marbles. And this is again not a table. This is a picture for fractions. If Alex gives a quarter, okay, so that quarter, 1/4, I need to know 4 parts. And this 9 must be the 3/4 he was left with. Take that 9 divided by 3, you're going to get, sorry, you're going to get 3. So each set has to be 3. Set or cell, the value of each cell. That's the explanation. So I'm going to just put my 3 here, 3 here, 3 here, 3 here. And I'm going to shade this something else. Let's just stick to green. All right. So if this is 9 coming from here, this has to be 3. And that means Alex gave Betty 3 marbles. If that's the case, give the 3 marbles back to Alex. That's 12. Betty ends up getting 18 minus 3 is equal to, I believe it's 15. Nothing happens to this. I'm going to quickly check my answer, 12, 15, 9. Sounds good. Now I will work on the answer and then I'll be happy to take some questions. So let me just make sure that my answer works out. I know it's right. I checked it, but you won't be able to check it on the exam, right? You won't have the answers. Okay, so if I start with this, and just walk in the right direction, not working backwards. Alex gives a quarter. A quarter of 12 is 3. So 12 minus 3 is equal to 9. And 15 plus 3 is equal to 18. Nothing happens. I have addressed the green sentence. Then Betty gives Chris 1/3 of her marbles. Come to Betty. What's 1/3 of 18? That's 6. So 18 minus 6 is 12. And 9 plus 6 is, if I'm not mistaken, 15. And nothing happened here with Alex. We have addressed the blue sentence. The last one, Chris gives Alex 3, so 9 plus 3. And 15 minus 3. I didn't do anything with Betty because she was not playing any role. So my answer has to be correct, not because it matched, but because, yeah, if you do all those things, you do get 12, 12, 12. Let's pause here a little bit, guys. Let's see what's going on. Excuse me. How do we feel, guys?
Pretty good.
Do you guys want to try one in class just to make it more fun and maybe share your screen or walk me through? What do you think? No pressure. I don't want you to, here's the deal, guys. It is an online class. I don't want you to like put pressure on you just because you're here. But if you're interested, do you want me to move on? We did 2 examples. I'll let you guys decide. What do you guys feel? How do you guys feel? I mean, we have a couple of options. I can give you one problem and you can try and do a little practice and then share, or I can do another one, or we can move on to the next one. How do you feel? Which one do you prefer?
I think I'm good. Sorry.
That's okay. Tell me your name. Is that
Jersey?
Okay, Jersey is good. What about the, Brianna?
Yeah, I think we're good to.
Awesome, awesome. So we're gonna move on, and I'm talking to everyone else who will watch it online. If you need help with this, come to class next class and say, you know, I'm still struggling. Can you answer this? How did you do this? That's why I'm here. That's why I'm going on. That's why I'm recording. I'm going on, maybe that too. But that's why we're doing this. So if you want to come, if you look at the video, like, well, I don't quite still follow. I will upload some extra problems. The videos are here, 2 of them, 2 of the solutions. I can do more, but you have to come to class and kind of tell me otherwise. I don't want to sit here and record the same thing over and over again, but good. Thank you. Once again, guys, the next problem is our last problem from this packet. Okay. This also came from a middle school text, so I will try to avoid doing a lot of fancy algebra. Again, I'm talking to everybody. If you do your fancy algebra on the exam and you're getting the right answer, I'm okay with it. I don't have any problem with it. But you should also know how to do it so that younger people can understand you. That's your goal, right? It says all that. Don't worry about this. It's going to be an online exam, right? So you can do it any way you want. As long as you got the right answer, I'll be fine. Okay, once again, this is a challenging problem, just like the previous one. I'm surprised that this Zoom thing didn't kick me out yet, but I'm gonna just keep on going. Okay, I'm gonna do again. This is a difficult problem. I will do at least 2 versions of it. So let's do the first one. Let's do the first problem, then we'll do one. I think your book has one. No, I'll have to bring a problem from another place. All right. Geraldine and Josephine baked 41 cookies. Okay. We don't know if it's 20 or 21. It's 5 or 41 minus 5 is 36. We don't know. Geraldine took 3/7 of her cookies to a family party. Okay, let's see if they can represent it. Okay. And I like to, when it's a difficult problem, especially for this problem, I like to draw a picture. It's a good way to record all the things that are going on here. Okay, so, and what happened, guys? Let me see. I don't like the formatting of this. Give me 1 second. I need a little bit of room. Do this one. Party. Home. All right. All right. So Geraldine took 3/7. So let's see how we can represent 3/7. What I'm really trying to do, guys, is this. Makes sense. And these squares are not cookies. These are parts of cookies. What do I mean by that? A square could represent 5 cookies. I don't know. Okay. So make it even bigger. So it makes sense to say each square, a black square, may represent, let's change the colors. It'll be a little more interesting. We could just say the blue and you would understand what I mean. Let's make it red. Okay, a blue square could represent 5 cookies. If that's the case, she took 15 to the party and 20 were left for the kids, for the grandkids. Now, the catch is I don't know if the blue square represents 5 cookies, 10 cookies, 15 cookies. It can be too many because they all together bake 41 cookies. So that's how I'm representing 3/7, and I have addressed this statement. I'm going to make this orange. This is a visual representation of the orange statement. What did Josephine do? She took 2/5 to the same party. I don't think it matters, but let's just say she took 2/5. And this is how I'm going to express her part. I'm going to use circles or maybe octagon, doesn't matter. Okay, I'm going to put 2 here. I'm going to put 5 here. Okay, these octagons represent 2/5, and that's going to be blue for me. And this represents the parts that stayed at home. These are not cookies. These are a certain number of cookies. I didn't want to use. I have 10 minutes, but guys, just to let you know, if they kick us out, I'm going to continue with this. If they kick us out, I'm going to come here, start from the same slide. No big deal. Use the same link to come back. But I have 10 minutes. I think I should be able to wrap it up in 10 minutes. I'll try not to rush. Once again, the green line is here. Orange line is here. Done. So far, I've just summarized what's going on. Now, I need to find the values of each square. By the way, the blue squares and the red squares are worth the same number. And the orange, this is an octagon, the stop sign. The red octagons and the blue octagons all represent a certain number of cookies. So take a look, guys. All of this has to be 41. Why? Because they together make 41 cookies. And Geraldine and Josephine took 17 cookies too. So we are also being told this has to be 17. Based on these two facts, how can we find out what each square is worth, what each octagon is worth? That's our goal. So far, we have just summarized the question or represented it visually. We haven't done a whole lot of math. So let's see how we can do it. So guys, in this kind of a problem, we're going to start with something big. Let's do it nicely here and go smaller and smaller. What do I mean by that? Well, this is 17 because that's the amount that went to the party. And this has to be 41 minus 17, whatever that is. Instead of 41 minus 17 is 24. Thank you if you were trying to help me. Okay.
I have a question.
Go ahead, I'm listening.
It says if Josephine took 2/5 of her cookies to the party, how come she took 5/5 home and not 3/5 home?
Thank you, thank you, thank you. Are you okay now? I appreciate that. Is that better?
That's better.
That was an error on my part. Thank you for catching it. Awesome. So this has to be the pink box on the right hand side has to be 24. The blue box has to be 17. Now what I'm going to do, I did the subtraction, you saw it. I'm going to erase this. I'm just going to write actually 17 here. I don't need the subtraction. And 41 minus 17 is 24. Here. Now the goal is to go from here, find the value. Now I'm going to see if I can explain it to you this way. So here I'm being told 3 squares and 2 octagons are 17. Take a look. This has to be 17. This has to be 17. If this is 17, change the color. This bit has to be, all of this is 24. 24 minus 17 is 7. So an octagon and a square has to be 7. I'm getting closer to my answer. Now I know a square and an octagon together is worth 7. What else can we do? Come here. Same. This is 7. This is 7. And this blue square is 17 minus 7 minus 7. 7 plus 7 is 14. 17 minus 14 is 3. So each square has to be 3. That's an important finding. I'm going to write it here. Each square is worth 17 minus 3. Now I'm almost done, guys. Come back here. The red square plus the red octagon is 7. If the square is 3, octagon has to be 4. Has to represent 4. We're done. We're done. Now the way I did it, guys, I'll tell you a little. Is that the exact same way you have to do it? Not really. You start with the numbers and try to find things that are smaller and smaller and smaller, and you will get to the right answer. Now the question says, how many cookies did each bake? Geraldine baked 7 squares. Each is worth 3. Geraldine This is my Geraldine. 3 times 7. And Josephine, 4 times 5. 20, and everything works out. Trust me, I remember vaguely looking at the answer. I got the answers right. And thank you, Brianna, for catching my mistake. And everything pans out. And this is my answer. A little bit of summary. It's going to kick us, the meeting is going to kick us out. Oh, we have time, 4 minutes. I will do another problem, okay, no matter what. I will do another problem like this in the next session. Again, we're going to I'm going to give you, we have 5 minutes here before the session kicks us out. The whole summary, the entire summary is take the question, draw the representations. By looking at the representations, try to find out what each symbol is worth. And how do we do that? Well, start with what's given, see if you can narrow it down, be narrow, get to the center. By center, I mean the value of each square, value of each octagon. I'll be happy to take some questions from people who are here. What do you think, the two individuals who are here? I'll try to avoid using your names, but what do you think? Does that make any sense?
Yeah, makes sense.
Good, very good. I will do one more. So guys, let's get out of this session. It's going to kick us out in like 2 minutes. Do come back. I'll do one more if you want me to do more. So we're kind of wrapping up this packet today. Let's go ahead and move on. Do one more like this. See you guys soon. I'm getting out of this.